Skewed versus symmetric distributions. All right, so on the screen you have some example of symmetric distributions. When a distribution is symmetric, it means that the mean and median are in the exact same location in the data distribution. And then it also means that the left-hand side of the distribution is a mirror image of the right-hand side of the distribution. So it's perfectly balanced around its median. Now, normally it's only perfectly balanced around its mean, right? So a data distribution is always balanced around its mean, meaning that there's always equal weights above and below the mean. But in a symmetric distribution, it's also balanced around its median, meaning that there's also equal weights above and below the median. And basically it means that the two sides of the distribution are mirror images of each other. So here's just three examples. We have a traditional bell curve, and that's got the mean, the median, and the mode all in one location. This is called a bimodal distribution. It has two modes, right? But the mean and median are right in the center. And of course, if you folded it over across that imaginary line down the center, it would be laying on top of each other, the two halves of the distribution. And then finally, the uniform distribution, this rectangular square distribution, the uniform distribution, also is perfectly symmetric around its mean and median in that case. Okay, let's look at skewed distributions now. So this distribution is left skewed. So remember, the skewness gets named after where its tail is located. So if it has a skinny tail on the left-hand side of the distribution, it's referred to as left skewed. And that name comes from the fact that this skinny tail, these extreme values that are low on the number line, end up dragging the mean down towards those very small values. Imagine if you had a class of 20 students and then 3 or 4 of them got zeros on the exam, or grades that were very close to zero on the exam. Their grades would drag down the class average, right? Pull it down towards those low grades. So the mean is being tugged to the left because of these values on the lower end of the distribution. Remember, the median is more robust, so it isn't as easily affected. So essentially, it remains the middle value, and the mean is tugged away from it by these lower values. And the mode is just where the highest peak of the distribution is. This mode isn't always in this location necessarily, but in a distribution like this, it typically is in that location. The mode is where the most repeated value occurs, right? So the highest peak of these curves is where the mode is located. In the right skew distribution, we have basically a flip of the last drawing we saw. This time, the skinny tail is on the right-hand side of the curve. These relatively high values or extreme values on the upper end of the distribution, they have a disproportionate effect on the mean, and they pull the mean upward. So this would be, for example, if you had a class of 20 students and a handful of students got perfect scores on the exam, but everyone else did kind of just okay or just sort of average, then the high scores at the very top end are going to pull on the mean, raising the class average. So the mean here is tugged or influenced by these extreme values on the right-hand side of the curve. The fact that the curve is skinny here means there aren't that many extreme values relative to the bulk of the data set, right? The median, as always, again, is more robust, so it isn't pulled as far to the right as the mean is. And the median is in the middle between the mean and the mode in this example. And the mode, of course, is always where the highest part of the curve is in your picture. So just try to remember what's important about these skewed distributions and the symmetric distributions is the fact that the mean and the median are in the same place in the symmetric curves. In the left skewed curves, the mean is to the left of the median. That's important, right? Remember, left skewed, the mean is on the left, the median is on the right. So in other words, the mean is to the left because of the skinny left tail. And in the right skewed distributions, the mean is on the right because of the skinny right tail. The mean is pulled towards those extreme values, and the median is on the left, right? So the mean is higher than the median in the right skewed distribution. It's lower than the median in the left skewed distribution.